Hi everyone, this is Prakash, and this is a session number 2. The session 1 was belonging to section A, where we focus mainly on the fundamentals of computer, and this is for the PG diploma in AI preparation for the C-DAC and other associated courses, like similar courses like what do you call the gate exams and all. So this is the language C session, and it's very important. It's a system language, and 90 to 90 plus percent of the uh, C is written. 90% of the Unix is written in C. In fact, the Linux is nothing but follow up on that. So most of everything is done in C. So let's bring in Jaymeet Vasava, who is our study circle lead, who started the computer fundamentals, and this is the section B, session 1, or if you count by number, it is session number 2 of the PGD AI study circle. I hand it over to Jaymeet. Go ahead, Jaymeet. Thanks for the.
Okay. Thank you, Professor, for the introduction. And hello, everyone. I hope everyone is doing fine. So today's session is about C language. Choosing C is because it's also a requirement for the PGDAI's uh, syllabus, as well as C language is also forms as a base language. And understanding C also gives us a good deeper picture into what are the things that advanced languages have achieved by automating the things that C was not able to. But uh, C gives us a manual power in order to handle everything manually and gives us a deeper understanding of how things work. So there is a short presentation for C language and its intro. So getting started, as we have so as any language we speak, we have our alphabets, then alphabets combined together for to form words, words combined together to form sentences, and sentences for paragraph. So similar is the logic for C. It has its own alphabets and digits, special symbols or characters, then constants, variables, and keywords, and instructions which are transformed to programs. So you can see the list of C characters that are available in C. Then on the left hand side, right hand side, you can see the constants, also called as literals, which constants don't change in value. Then there are variables which can be assigned to any given name. So a given variable, let's say x, then x will hold a place in memory, and that x can be pointed towards any value that it can be used to store. If x has equal to 1, then it will store the value of 1. And if holds the value of 5, then it will point towards the value of 5. Then also we cannot use anything in C. Not everything is usable, which are the keywords that are already uh, within the C. So you can see the keywords listed below, starting from auto and ending with while. So these are the keywords that has some meaning in C, and it should not be used unless the functionality which follows it are to be intended to be used by the user or the programmer. So there are primary and secondary constants within the C. So there are integer constants with having their own uh, rules to follow in order to define it. Similarly, they have the real constants and the character constants. So an integer constant must have at least one digit. It must not have a decimal point. It can either be positive or negative. Then no commas or blanks are allowed within an integer constant. Then if no sign precedes an integer constant, it is assumed to be positive. So it means that a positive integer can be uh, displayed in two manner, without the positive sign or the plus sign, and with plus sign. Then the allowable range for integer constants, you can see -3 to 768 to 3 to 767. Then there are real constants. So the real constant must have at least one digit. It must have a decimal point. It could be either positive or negative. If no sign precedes a real constant, it is assumed to be positive, and no commas or blanks are allowed. So you can also see the example of the real constants. It has decimal points to it, and other you can see the exponents of it. So e minus 4 symbolizes the exponent, and how exponents are defined within C. Then there are character constants. So a character constant is an alphabet, a single digit, or a single special symbol enclosed within a single quotation. For example, S is a valid character within single quotes, whereas S with double quotes is not as it is enclosed within double quotations. The maximum length of the character constant can be one character. The C compiler allots 1 byte of memory, which is 8 bits, and you can see the examples for it. Then there are secondary constants, which are arrays, pointers, structures, union, enum, etc., which will be covered further in different sessions. So this is the first C program would look like. So we start, which is a hello world, which is a classic and a simple example to start with to anyone who is new to C. So first, the program starts with hash include. So hash include is used to include the functionality to the file, to the program. So C is whenever a C program is used, it does not include each and everything that C can be do. C is capable of doing, but rather it includes the files which holds a particular functionality to it, and those functionality are included within the program that the user of the program is using, is done with the help of header files, which includes the functionalities. So we can see that we have included the header file stdio.h, which is .h for header files and stdio for standard input output for printing the statements. So we included the standard input output header file. Then we shift to main, which is the second line of the program. So main is the main file of the program, which will be containing all the, which will tell the C program to start, and it will be looking for its execution. Then within that, the main uh, function starts with curly braces, and everything within will be executed. So we have the printf statement within it. So printf statement is used to display something out on the screen. So you can see that we have used hello world, and then /n. So /n is used for a new line, and it will print the word hello world. So just different additional points to it. Just how to run this program depends on the system you are using. As a specific example, on the Unix operating system, you must create the program in a file whose name ends in C.C, such as hello.c, then compile it with the command say C hello.c. Then if you haven't mistakenly done something, anything wrong, so such as omitting a character or misspelling this something, the compilation will proceed silently and make an executable file called a.out. And if you run an a.out by timing the command, it will print the word hello world. So this can be done, or you can also use online compilers for practicing the C programs as well. So this is the same C program for Hello World with its different kind of explanations. So here you can see the int main void. So void actually means void within the main brackets means that it is not going to take any arguments. Int is the value that main function is going to put out. So it's going to be an integer. Then we have the different rules. So semicolon is used to signify the end of the statement. Then there are different use of comments. So double slashes are used for single line comments, and slash asterisk for a multi-line start of the multi-line comment, and asterisk slash for ending the multi-line comment. Then there are print statements, of course, printf actually, and then scanf statements. So scanf statements are used with header file of conio, console input output header files, where it is where an input can be taken. So if the input is taken in the form of integer, a percentage or mod d is used, and if for the place value of a variable that is defined here, it is an example of a, an ampersand is used before the variable's name for storing the address, for using to store its address. Similarly, for the float and variable of any name variable b, the address of b, and for character mod c, and address of c. So these are the format specifiers and the data type, and that can be used whenever we run a program. So starting with character, unsigned character, int, unsigned int, short int, and long int. So short int and long int includes different ranges of the integers. And then there are float and double, long double, and etc. So there are types of instructions. So there are declaration instruction for declaring the variable, and arithmetic instruction for doing the arithmetic operations. So you can see the arithmetic operators and the description, as well as the priority to it. So if within the arithmetic operation are defined, and the line has to be written in a way that is intended to be used by using the arithmetic operators in that order. So the execution occurs in the intended way. So the first priority is given to multiplication, division, and mod for the remainder. Then plus minus, then plus minus, and then later on the last for the assignment operator. Then there are control instructions to control the sequence of the execution. So now we will start with the if statements. So if statements are as so let's say as you can see that here we have printed the statement hello world. So what if we want to print the statement multiple times or automate something within the program? So for that different loops are used. So loops and statements are used. So we are starting with these three major decision-making statements. So first is if statement. So if statement is done with, so you can see the syntax to it. First is the if statement, then it specifies a certain condition, and if the condition is true, it will execute the block which is within the if statement. So you can also see on the right hand side the execution the flow chart of if statement, which has a condition. If the condition is true, if statement will be done. If false, it will again check for the condition and then exit the program. Similarly for the if else statement. So if else statement is done if the condition is true, the true condition will be executed, and if the condition is not true, and then the condition, then the statement after else will be executed, and you can see the flowchart of the if else statement too. So for this example, let's see the example of if statement. So you can see we started with include and stdio.h. Then we started with int main, and we started with int gfg equals to 9. So if gfg, so we started the int if statement, and then we gave our condition. So if gfg is smaller than 10, which is true right now, as 9 is the value. So we will print this printf statement, which is percentage d for displaying the integer, and with the value of gfg. So as we have the true as our statement or condition is being satisfied, the if statement is being executed. But if, let's say, the value goes to 11, then this block will be executed. Just a second. So so actually, okay. So this is the example for if else statement, actually, not this one. Uh, so for if else statement, you can see that first is this one. If the condition is true, this block will be executed. But if the condition is false, is not met, then this block will be executed within the else block. But if we want to, these are for only two conditions. But what if we have multiple conditions to meet? Then if else ladder is used. So this is the example of if else ladder. So for we start with n equals to 0, int n equals to 0, and if n is greater than 0, we print positive. If n if n is less than less than 0, then we print negative. And for the last condition, uh, we have the print statement. If it does not satisfy any of it, then it will be satisfying this condition for it being equal to 0. And here return 0 is an exit code where it shows that the code above is has been executed perfectly, or with the intended errors, with the intended manner. So return 0 is an exit code, so it will print 0 in the end. So I also showed you the if else statement, or so this is the flowchart diagram of if else if letter. So if else, so the reason there is a second option to if else, which are the switch statements. So the problem with if else is that if else ladder is that if there are too many statements, it can be unreadable in a way to follow what the code is doing. So that is when the switch statements come into picture. So you can see the flowchart diagram of it. If the condition is met, it states a switch statement, case statement, and then executes it and goes to the end of the terminating the program. If false, it checks for another condition, and so on. And there is a default condition to it if none of the conditions are met, and then it goes towards the end of the program. So this is what the switch statement looks like. Starting the program with header files, and then int main for the execution of the program. Then we specify the variable, which is int var where, and then ask the user for entering a number. So printf for printing the statement, and scanf is for asking the user for storing the user's input. So as the value of where is an integer, a percentage d is used, and then a percent var for storing the value of percentage d within the var. So from here, the execution of the switch statement starts. So we have got the condition here. Then we have the case. If the printed value is 1, it will execute this and will break, and then return for and will end the program. And this is the same for case 2, case 3, and a default for not matching any of the case if it's needed, and then in the end return 0. So similar to that, we have different loops. So we have for loops, which is used to iterate over a code to be executed for the time when the condition is met. So we have start, and you can see the flowchart diagram of for loop. We have start initialization of the code, check for the condition. If it's true, executes the block of code, and then updation, and then check. And if so, for loop is used until the condition is met. As soon as the condition is becomes false, it goes to terminate the program. So this is for this is the example of the for loop. The int main to start the program, including before that including the header files. Then int greet equals to 0. We specify a variable with int and its value to be equal to 0, and then we execute a for statement. So here the for syntax of a for loop is mentioned. First, the initialization of the loop, the termination, and the incrementation if needed. So incrementation to it, and then executing the line. So you can also see the line one by one execution of it, of how for loop will be executing it. So we started with uh, to check and test the expression. The loop will function if only if greet is less than 5, and then greet plus plus is to increment the value of as we started with a greet equals to 1, it has to increment. So increment will be done in the last so next we have while loop. So while loop is used to iterate a part of code while the condition remains true. So you can see the flow chart to it. So test condition, if the condition is true, execute the loop and go on to further. And when the false statement is met, the loop ends and breaks out of the code. So similar to for loop, we have a while loop. So this is starting with header files, then int, and then the program. So we have the variable as I, which is equals to 0 for for I being smaller than 5, we'll be posting this and then incrementing the value of I. So next is the do while loop. So a do while loop executes a block of code repeatedly for as long as the condition is true. However, in contrast to while loop, it is guaranteed to run at least once, regardless of whether the condition is true or false from the beginning. So you can see the flowchart of the do while loop. So execute the loop, then check, test the condition. If it's true, it goes, it executes uh, and keep on executing until the condition met is true. And if it goes to false, it goes to end the loop. So this is what the do while loop looks like. So we have the variable here. Then we have the starting of the do while loop for. So this do loop will be keep on getting executed when until this while condition has been satisfied. As soon as the while condition is not met, it will stop. It will stop its execution. So there are also different kind of operators in C. So you can see there are operators and then type. So plus plus minus minus, and these are unary operators. Then arithmetic operators, then relational operators, logical operators, and then bitwise operators, assignment operators, ternary or conditional operators, which we'll be using or watching for uh, in different sessions while executing the programs. So these are the references used for this and the online compiler that was used. Uh, before before ending this, I would like people watching this to execute this program, as Hello World is the classic and simple example for explanation or of C program. This is a Fahrenheit Celsius table. It's also uh, a classic introduction to the people who are starting to look for learn C. So so this is a Fahrenheit to Celsius table program. I would like everyone to execute this and see the output if it matches or not, or what other things you are able to do it with this very program other than this. So thanks a lot for listening, and thank you.
Jaymeet,
Oh yeah,
thank you. Thank you for the excellent presentation. And as an introduction to C, this is a good beginning. What I would say is you had references, right? So can you show your references? Yeah. So you have taken a lot of stuff from Yashwant
uh,
Connect. Let
yes.
us
Let us see.
yeah, let us see. So the origin of this C programming goes back to Dennis Ritchie, who was the first what you call uh, first developer of operating system called Unix, and there he started using language based on past languages like B and BPCL and then eventually evolved to C. And in the first version, when he released in 78 this book, at that time they were trying to address the standardization through ANSI, American National Standard Institute. So ANSI 78 standard is what initially they started with, and then followed by Cunningham, Brian Cunningham, who joined along with many stalwarts. He eventually wrote the second edition with the help of Dennis absorbing all the thing, and uh, some of the programs like you showed the centigrade Fahrenheit temperature example, they are from the other book, which is the uh, Cunningham and Ritchie, which is a very classical book. And anybody who has done computer science the 80s and 90s, and even today, they vouch for this book being one of the best books. Uh, and rightly because it was from a very, very, what do you call, uh, raw start where a single person built uh, compilers. So compiler construction is a big thing because you have to go through the symbols, you have to do the keywords that are there, like Jaymeet mentioned earlier. Those reserved words are keywords. One has to look at a line, line by line, and you have to pass through the text, first pass, second pass, etc. So sometimes it is one pass, sometimes it's two pass. Generally, compilers have to have two pass. First pass, you go through and find out what are the keywords, and what are the variables and all that. They are all tokens. What are the tokens? They are all set. And there is a uh, great tool in Linux, on Unix called YAC, yet another developer. Usually YAC, a tokenization of the text, and that is why the way they are written are very, very formatted. Like you start with the hash sign for the standard stdio.h file. So if you open the stdio.h file, it's a header file. It contains all the sources of the how to do the input and piping, pipe in, pipe out, which is what we use in the shell scripts and all that. So those are all exclusively included in that part to be able to do input, output, redirection, write, read, and all that. So those are all avoided in the compiler usually. They try to the C language avoids them. It focuses mainly on computation basis. Either you compute or you the data processing in the system. If you are using character processing, type is a very important concept which was brought into C earlier, like type, integer type, float type. Then you got the what you call the additional we call constants as strings. So all the processing, even though strings are processed as arrays, uh, but those are not really inside. They are again outside library. So most of the things fall into library, strings library, standard library, time library, and whatnots. So usually you will find that everything that is composite is generally thrown into what you call the libraries, so that you can load it while you compile, load and link. So your code, what you write, source code, it is uh, loaded into memory, and then along with that, uh, program counter, which is increments by execution of instruction. That is again uh, pointing to the uh, sequence of program that is being executed in the runtime. At the runtime, they after compilation they got some kind of a code or an object. So source code and there is an object code. And in the object code, they also link all the libraries and then execute using the program counter step by step as it goes from the memory. In fact, a lot of stuff we have in the stack like push pop, and obviously the concept of memory management is very, very uh, I would say primitive or direct in case of C, where they generally keep static the allocations, and so therefore you'll find that there are many terms like malloc and alloc, and so how do you want to allocate the memory for a given, and then there are some pointers and arrays, and so various structures. So those are all part of the C language as it evolved, and the core C is very, very minimal. Its footprint is very low, so it can be loaded in a very, very smallest of the computer, even in microprocessors and all. So the idea is to keep the low footprint, bring whatever you need whenever you need, load them and link them, and then execute them. So the C language is really a very fantastic language. In fact, that is the one which actually promoted the early uh, as a system language because it deals with the system, but at the same time one of those languages where you have got uh, no dependency on hardware or independent of hardware, we call it. There are some situations where it does, but that are very minimal. So if you have a C code, you can really take that code on any computer to any computer and it'll work. So portability was one of the criteria which which was very stressed in those days, early days, because there were not many uh, clean, as clean a compiler, because they started in different angle with Fortran formula transmission, where the focus was mainly on the what you call the computation, high, high, that is high, more like more of a scientific computation. But then the business languages at those days were COBOL, which was more of a business oriented, where the data division and working division, the data was more important for business processing. And this C is the one where it combines both of them and handles them very efficiently and with the simplicity of um, like a charm, you can code without really creating any or a big, huge program. So that's the reason that C compilers have prospered. And then there was, of course, the moment in 19 by George, what is his name, GNU, copyright and copyleft, and there are many, many battles for keeping it open to public. Today, you can find if you use a Linux, you'll find the compilers easy to use, GCC and GDB. So I think I saw Jaymeet use GDB, which is nothing but GNU debugger, and their evolution has been very, very uh, phenomenal. Put it, several of contributors in the open really contributed to the growth of C. Ultimately, the Unix operating system got what you call AT&T was the owner of that. They put it out, and Berkeley took it, and there was a Berkeley Unix, and ultimately Linux is the current uh, version of the operating system that is most used on all sizes of whatever the requirement is, except that for some of the office work, generally Windows is preferred because of the ease of use. Of course, Mac is another one which is more of a media application, games, and all that. So everybody has its flavor, but main point to remember in C is that C is applicable across all platforms. Windows use it, even what do you call the Mac uses it, and all of the Androids and iOS. iOS is a bit of a C form types of usage, but still it is a C variants of C, mainly to make sure that C is one of the longest surviving. Like if you compare that, Python is another. So currently, these two are the main contenders to be able to continue in the growth process. Of course, there are very specific languages like Rust, and there are many more like Go, which have also got prominence for certain one or the other reason. But C and Python, literally, with the in between Java being the object oriented, there was this, in fact, Brian Cunningham and Dennis Ritchie even acknowledged that John Strossop, who was a C++ expert, they have borrowed a lot of elements from C++ into this to make it very, what do you call, modularized, even though they don't call it object oriented, because the concept of object oriented is more in C++, Java, Python, and other languages. More of the C programming goes well with the scripts, like a K shell, bone shell. Most likely K shell is the most standard. And then you got Bash. This is a bone shell which is used in Linux. So Bash is a very, very commonly used. Earlier there used to be many other shells, but Bash has survived. And so when we talk about the scripting and shell programming, we'll go and look at Bash as one of the components to be able to do. uh, layered over the Unix or Linux operating system, whatever is the core. On top of it, how the command line is used. A lot of these days, people prefer to use the what you call the graphical user interface or IDE. They call it as interactive development environment. But older folks would be using either Emacs or VI editor to write the code. So they use the Visual Editor VI and then code it on the fly system and compile it, build it, and load, link, compile, and then build object code and then execute the code. So that's still standard for many of the older stalwart codes, but others prefer to just these days even generate like which is a part of AI. So you'll find that these are some of the things we'll observe. So essentially, what today Jaymeet has achieved is he has tried to explain what are the various steps, what are the various elements of his program of C program, what are the sections, what are the syntaxes, and how you can do compilation, how you can execute, how you can define variables. So simple things. What are the loops, control loops, and what are the if loops and while loops, and how do you end it, and how do you task repeatedly uh, without having to have recursion. Looping can take care of most of the uh, tasks which are done repeatedly with a plus plus call which is used in I plus plus, J plus plus, and place the values. And then, of course, there is more to come as you will see in the next sessions. And we hope we'll be able to justify, just do justice to the subject of C, the what do you call the uh, most most used uh, system language because it is neither too low nor too high. People don't use assembler. Rather, people normally earlier days people used to use assembler. Machine codes followed. Then after machine code, they started using assembler based on the operation and operand with the register level programming and all that. This register level programming is all taken off. It's just memory. You manage your memory and write your program and load it and execute it. So this is much uh, lower, yet at the same time it is abstract in the sense it is portable. So I would say that at this time we have had sufficient information for you to leverage and go and read these books. And obviously, we'll continue. There are another four lessons on C programming, and I'm very happy to see young Jaymeet provide you all the necessary material which you can use and leverage and try to execute. And we'll also add few exercises here and there to see that this program becomes so smooth for you to be able to actually leverage and appear for the point. And with that, Jamie, anything you want to add?
No, nothing right now.
So we'll see you then on the alternate day, right? So this is
Yeah.
uh,
Now on Friday.
we'll see you on Friday. So everyone, thank you very much. So we'll see you on Friday, and please go through all of this. And if you have any questions, please get back to the meetup link or to the PGD AI or info at uotf.in, and we'll try to respond to you. Okay. Thank you very much. And with that, I'll stop recording.